Welcome back to the GS Mindmap Channel. Today, we're bringing you a massive, high-yield explainer covering the entire Class 6 NCERT geography syllabus in one absolute shot. If you're a focused learner gearing up for competitive exams, or honestly, just someone who loves understanding how our world actually works, you are in the exact right place. We're going to take a spectacular macro to micro journey today. We'll start all the way out in deep space and progressively zoom inward until we land right on the diverse climate and geography of India. We'll be using our clear, structured mind maps to make sure every single high-yield fact sticks in your memory. So get ready to supercharge your revision.
Okay, let's dive right into this. Here is our roadmap for this explainer, condensing 8 chapters into 5 easy sections. First, Earth in the solar system. Second, globes, latitudes, and motions. Third, understanding maps. Fourth, domains and landforms. And finally, India's geography and climate. Let's get moving.
All right, kicking things off with Section 1, the Earth in the solar system. When we think about our own planet, a really vital detail emerges. You've probably heard Earth described as a perfect sphere, right? Well, actually, scratch that, it's technically incorrect. Earth is what we call a geoid. This means it's slightly flattened at the top and bottom poles, and it bulges out at the equator, so it looks a lot more like a rugby ball than a basketball. Make a huge mental note of this, because the term geode literally means Earth-like shape, and it is an absolute favorite trick question for civil service and competitive exams.
Now let's do a rapid-fire check on the inner planets. Keep in mind that, unlike stars which emit massive amounts of heat and energy, planets don't actually have their own light. They're illuminated by stars. First up is Mercury, sitting closest to the Sun and whipping around it in a rapid 88 days. Then we have Venus. Venus is fascinating. It's widely known as Earth's twin because its size and shape are so incredibly similar to ours, but Venus has a massive quirk. It rotates in the exact opposite direction to Earth. Then there's our home, the Earth, sitting safely 150 million kilometers away from the Sun. Because 2/3 of its surface is covered in water, it shines like a jewel in space, earning it the title of the Blue Planet. And hey, just a quick bonus fact here. Our nearest companion, the Moon, is only about a quarter the size of Earth. It sits 384 kilometers away and takes 27 days to orbit us.
Moving swiftly along, we transition from the broader solar system down to the invisible grid that wraps around our world in Section 2, Globe, Latitudes, and Motions.
We organize our planet spatially using a grid system. Think of it like a giant puzzle. First, consider the horizontal lines, the latitudes. The equator sits directly in the middle at 0 degrees. Above and below it, you'll find the tropics of Cancer and Capricorn at 23.5 degrees north and south. These lines perfectly define Earth's heat zones. The torrid zone, right around the equator, gets the most direct sunlight, making it the hottest. As you move away, you hit the temperate zone, with moderate temperatures, and finally the frigid zone near the poles at 90 degrees north and south, which is literally freezing cold. But what about the vertical lines? Well, those are longitudes, and they're the secret to deciding the time zone of literally any country. The prime meridian, or Greenwich Mean Time, sits at 0 degrees in Britain. Because the Earth rotates 4 degrees every minute, which is 15 degrees every hour, moving east adds time. And this is exactly why India's standard time sits exactly 5 hours and 30 minutes ahead of Greenwich Mean Time. Pretty cool, right?
So the crucial point here is understanding how the Earth actually moves through this grid. There are 2 distinct motions you absolutely must never confuse. First is rotation. This is the Earth spinning on its own axis, much like a top. This daily spin is exactly what gives us day and night. Versus revolution. Revolution is the Earth's annual journey moving completely around the Sun on its orbital plane. Crucially, Earth's axis isn't perfectly straight up and down. It's tilted at an angle of 66.5 degrees to its orbital plane. This specific tilt, combined with the revolution, is exactly what creates the changing seasons we experience throughout the year.
Let's map out exactly how that revolution plays out over a year. On June 21st, the northern hemisphere tilts toward the Sun, giving us the summer solstice. 6 months later, on December 22nd, it tilts away, bringing the winter solstice. But think about March 21st and September 23rd. These are the equinoxes. Let me prompt your active recall here for a second. Why do these specific dates matter so much? Well, it's because on these 2 days, the direct rays of the Sun fall exactly on the equator. Neither pole is tilted toward the Sun, which gives us perfectly equal days and equal nights across the entire globe.
All right, let's move right into Section 3 and see how this builds into understanding maps. We've mastered the 3D globe, but navigating our world usually requires projecting it onto a flat 2D surface.
Maps are essentially flat drawings of the Earth's surface according to a precise scale. For your exams, you really need to know the three main types of maps. First up, physical or relief maps, which track natural features like mountains, plateaus, and rivers. Second, political maps, which draw the invisible boundaries around cities, towns, and countries. And third, thematic maps, which focus on highly specific data, like mapping out forest cover, rainfall, or railway lines. Now, to read any of these, you rely on the three core components of maps. Distance is managed by a scale, which is the ratio between the actual ground distance and the mapped distance. Direction is guided by the four cardinal points on a compass: north, south, east, and west. And symbols are universally agreed upon signs for things like temples, roads, or bridges. Here's a real game-changer distinction for your exams. If someone draws you directions on a napkin from memory without a proper distance scale, that is not a map. That is simply a sketch.
That brings us to Section 4, Domains and Landforms. We're zooming in even closer now, looking at the foundational physical layers that make up the planet's environment. The Earth is broken down into three major domains. First, we have the lithosphere. This is the solid portion of the Earth containing the crust and the continents where we actually live. Second is the atmosphere, that vital layer of gases surrounding the Earth, stretching up to about 1,600 kilometers in height. And third is the hydrosphere, comprising all forms of water: ice, liquid water, and vapor. Here's a wild fun fact for you. 97% of the Earth's water is found in the oceans, making it way too salty to drink. And where these three domains, land, air, and water, interact, we get a narrow zone called the biosphere, which contains absolutely all forms of plant and animal life.
Speaking of the atmosphere, its composition is beautifully balanced to sustain life. A massive 78% of our atmosphere is nitrogen, and nitrogen is incredibly important because it's essential for the growth of living organisms. Then we have oxygen, making up 21%. This is literally the breath of life for humans and animals alike. The remaining 1% is made up of other gases like carbon dioxide and argon. Now, carbon dioxide might be tiny in percentage, but it plays the massive, absolutely crucial role of absorbing heat radiated by the Earth to keep the planet warm, and it's completely essential for plant growth.
Finally, we reach Section 5, India's geography and climate. We are zooming all the way down from deep space to focus on the unique geography of our specific target country.
3.28 million. That is the total area of India in square kilometers. It's a massive peninsula surrounded by water on three sides. You've got the Arabian Sea on the west, the Bay of Bengal on the east, and the Indian Ocean down to the south. This is a foundational, highly testable statistic that you absolutely need to have locked in your memory for sure. India's immense physical layout is deeply tied to its unique climate. Spanning roughly 3,200 kilometers from Kashmir in the north all the way down to Kanyakumari in the south, this vast size means incredible climate diversity. But the defining feature of India's climate is definitely the monsoon. The word monsoon actually comes from the Arabic word mausim, which simply means seasons. During the southwest monsoon season, winds blow from the Arabian Sea and the Bay of Bengal, carrying massive amounts of moisture. When these winds strike the mountain barriers, boom, rainfall occurs, dictating the agricultural rhythm of the entire country. This rich monsoon climate directly supports India's incredible natural vegetation and diverse wildlife. I mean, it's the exact reason we have lush forests that provide a natural habitat for our national animal, the tiger, our national bird, the peacock, and even the one-horned rhinoceroses in Assam. We have covered an immense amount of ground today, journeying all the way from 150 million kilometers in space right down to the precise mechanics of India's monsoons. I want to leave you with a final thought to test your memory. We mentioned leap years earlier, right? So can you recall exactly why February gets an extra 29th day every 4 years? Think back to the Earth's revolution around the sun. It doesn't take exactly 365 days. It actually takes 365 days and 6 hours. We save those 6 extra hours every single year, and over 4 years, they add up to exactly 24 hours, or 1 full extra day. Just like a giant puzzle falling into place. Keep making these connections, guys. Review these mind maps, trust in your structured learning, and you will absolutely ace your exams. Thank you so much for joining me on this explainer, and stay curious.